Well, hello, friends. Welcome back to the JavaScript bytecode project. We are just going to continue. So if you haven't seen the earlier videos, I really recommend that you start at the beginning of this series so that you can have the full context of what we're doing. Today, we're going to add support for object property lookup to the bytecode VM. So we'll support a program like I don't know, something like this to begin with. So if we try to, if we try to run this, then it should fail to generate the bytecode because we're missing some support for these AST nodes. Right, so missing generate bytecode. And the new nodes here are object expression, this guy right here, and also an assignment expression that has a member expression on the left-hand side. That's something that we don't handle. So let's go ahead and add these things. So first thing is we'll add the code generator function to object expression. So that's optional bytecode register, generate bytecode, bytecode generator. And that would look something like object expression. So what does this thing do exactly? In this case, we simply want to instantiate a new object. So we want to allocate a new object from the GC heap. And I think for that, we will need a new object opcode in the bytecode. So it would be something like generator emit bytecode op new object. We already have new string to create new primitive strings. So new object seems pretty reasonable, and I guess we will store it in a register. So generator allocate register, and then if this object expression has a bunch of properties, which we don't have here, but you know, if you do something like if you set, wait, that's not how you do that. Like this sort of thing, right? Then this would be a list of properties that we need to compute and assign to the object. But let's only stick with the empty case. So we'll do something like this. If mProperties, if it's not empty, then to do. Yeah, we'll say a to do. And we don't handle that case. And then otherwise, everything is good, and we just return the register. So this is a very simplified version of the new object functionality, although the new object opcode doesn't need to change. I think we would still use a new object opcode, and then if there are properties inside of the object, then we would simply generate bytecode that would instantiate each of these as well somehow. But let's just ignore that for now, since we don't need that for our test case. So new object, and just a register destination, I think. Yeah, this thing really just needs to make a new object and assign it to that register. So nothing fancy. And wait, is this maybe even enough for just that initial, for the initial part of the AST anyway? Like, we're still going to fail with the assignment expression because of this member expression, but it would be cool if we could commit this separately. Oh shoot. I didn't even implement the execution of the opcode. It's just sometimes I imagine how I'm going to implement something in my head, and then it feels like I've implemented it. It's a bit of a weird problem. So new object to string, and this is really simple to stringify. It's just new object because it has no. I mean, actually, it does have the destination register. So I was thinking we could get away with no string formatting, but it does have a destination. So, oh, and let's put it next to new string actually, since they are kind of spirit buddies. Okay, and then new string, new object, execute, interpreter. So really the same basic concept as creating a string, except we don't have a string. We just want to create a new empty object in the current global object environment. I think that would do it. Yeah, wait, what's failing here? Generate bytecode. Assignment expression. Is that line 93? Okay, so we're hitting this to do an assignment expression. Sure, that makes sense, but what if we didn't have this last line here, just to test it out? Right, so if we only have O equals object expression, then we get this bytecode. So new object, stored to register 1, set variable O to register 1. And then we end up with register 1 containing a new object. So that totally works. So let's commit this little thing here just separately because it's so neat. Nice and tidy. Add a new object, bytecode instruction for object expression. Yeah, that's pretty cool. And then I guess let's get on to the next thing. So what do we do? Assignment expression, when there's an identifier on the left, it just means that it's a variable assignment. But when there's a member expression on the left, that means that we are assigning to the property foo on the object O. But both the children of member expression are expressions. So you could have O.foo, but you could also have like an expression dot something, I guess, or an expression bracket something. Can you do that? I'm going to test that with V8. Like a or 1 plus 2. Yeah, you can totally do that. Can you do this? To string. Yeah, you can. Okay. So you can do pretty weird stuff. So we need to handle all kinds of things on the left and right side of this member expression. So we'll start out by just asking, is the left-hand side a member expression? Okay, so we're assigning to a member of something. I think maybe we will do this. So we'll just cast the left-hand side to a member expression once we've determined that that's what it is, so that we can peek into it. And then we need to start by computing the base of it. So I forget what it's called. So member expression has two children, object and property. A property can be computed. Computed means that it's using brackets like this instead of dot. Well, the JavaScript is weird because you can do like this, and then O.foo is that property, but you can also access that same property like that. So both of these are member expression. This one is a non-computed member expression because it has an identifier as the property name. And this is a computed property access, computed property member expression, because the expression within the brackets is actually computed at runtime. So you can do this, right? And it gives you the right property. Very curious. So we need to compute some things. But I guess that just means we need to generate a bunch of code. So if we want to start by, what do we want to do? We want to generate code for the expression, generate bytecode, and this will be our, not for the expression. We want to generate for the object. Yes. So that's the O part here. And we'll store that into something. So like, we'll call it the base, or maybe object reg is better. And then we need to also compute the other side. So property reg, I guess. Property generate bytecode. Does this make sense? I guess, hold on. If the thing on right side of the dot is an identifier, then we don't want to necessarily generate this bytecode. So I think we gotta branch on is computed. So computed means bracket access, and let's just to-do bracket access for now. And if it's not computed, then we can verify that the expression property should really be an identifier. And then we don't need to compute anything there, but rather we can use the identifier as the property name to perform some kind of lookup. So we want to generate bytecode that does a lookup in the object with the property name. Okay. So generator emit bytecode up get property value by name, or get property value. So what I remember JavaScript core calls this a get by ID, like because you're doing a lookup and you're passing an identifier as the sort of the index. But I don't know if I like that name. It's like it's burned into my memory from hearing people talk about get by id this, get by id that. You got to make get by id work. But I feel like the name is a bit too short and weird. Get property value by identifier. That's so chunky. Maybe I should just call it get by id as an homage to WebKit. Maybe that's what we should do. You know what? We're gonna do that. This one goes out to WebKit, which already has get by id. So we'll call it that too. So we want to emit one of those, and the destination, we need to store this somewhere, so it needs to go into a destination, which we will allocate from the bytecode generator and store that there, and use the object register as the object, and finally also the identifier on the right side of the member expression. Man, this is a bit, it's a little bit tricky to keep all of this in my head at the same time, but I think we're doing okay. So that's the expression property dot string. Okay. And the result of this goes into the destination, right? So then we just return the destination register. Wait. No, we don't. What am I doing? Get by id. I'm confusing things here. We don't want to get by id, because that would be fetching something. This is an assignment expression. We want to be put by id. Right, so we want to put something into the object. So the destination goes first, since we're doing destination first Intel style, which means that we have a source, and the source must be whatever's on the right-hand side. So this actually should be a right-hand side register, which we will get from generating the code for the right-hand side. And then we will just pass that in. Man, I got this backwards. Okay, see, that's why I was saying that it's hard to keep this in my head, because it was all backwards. Yeah, that's what we want to do. We want to put something into the thing, because it's an assignment expression. That makes more sense. Okay. So let's go and sketch out this opcode. So put by id, final, public construction. So put by id takes a register object. I guess, do we know that it's an object on the left side always? I guess we don't necessarily know that. It might not be an object, so we have to call toObject on it to make sure it becomes. Yeah, that's where I keep thinking base. Like, we just call it base because it's the base of the property access, and then we'll turn it into an object in the logic. So let's just do it this way. And then we'll have fly string property name, I think, and then the source register. So yeah, this will be okay. Sure. Fly string. Okay. And let's do those virtual things here as well. Cool. Put by ID. And then how do we implement that? Also, it goes before jump. I don't know why. Maybe we should alphabetize these instead. I don't know why I'm keeping them in this weird order. Okay, so let's get back to how we implement that in a second and think about stringification first. So put by id to string. Put by id. So it has a base. Property name. Maybe we'll just call it property, actually. Source. Yeah, that'll be fine. So base, property, source. Property name was a bit excessive, because you know what it is. Cool. So what does this thing do? Interpreter. Well, it does. First thing we gotta do is try to get the object. So we'll try to convert the base to object. If that throws an exception, then we'll just, we'll just do nothing, and then the main execution loop will take care of the exception. We didn't get to dealing with exceptions yet. I'm just saying this as if it already does that. But eventually it will take care of it for us somehow. I think that would be a good programming pattern for these opcode implementations. If some exception happens, then just return, and then the main execution loop will take care of the exception. So object put, here we just need the property name and the value, right? So interpreter reg m source. Yeah, actually, okay. That looks really reasonable. I don't know if I got this right. Yeah, probably I didn't. But it somehow feels goodish. Did I mess up? Put by id. Object. Oh, wait, that's optional. Yeah, I still keep forgetting that generate bytecode returns an optional register. I don't know, maybe it's not worth returning optional register. Maybe they could just return register, and they could use register 0, and it wouldn't matter because nobody uses it accidentally. I don't know. But this more explicit style of like passing an optional, it does have some benefits in that it actually forces, it surfaces the fact that the returned register is used in the places that it is used. If we were just returning 0, and then it will be harder to spot a situation where the register should be used but is not, or should not be used but is. Is that right? I don't know. Anyway, let's not overthink it. So this ran. Okay, so let's look at the program because I forget what it does. Okay, so create an empty object and then set foo on it to 1, 2, 3. And first two opcodes, new object, sure. Assign it to O, sure. And then this expression right here turns into, first we get the variable O, put it into reg2, and then we load the constant 1, 2, 3 into reg3, and then we finally do a put by id with reg2 as base, property name foo, and reg3 as source, which means reg3 is 1, 2, 3, reg2 is the base. So this actually looks totally right. So I think this does the right thing. Although I guess we won't actually know if it does until we add code to also read from a property. So let's also do that. But you know what? Let's commit this stuff that we just did, and then just we assume that it was correct, and then if it wasn't, we can patch it up afterwards. But it's just nice to get these. It's pretty cool if you can get like a 1 bytecode into 1 commit like that. Add put by id bytecode instruction for object property assignment. Note that this is only used for non-computed accesses. Computed access is not yet implemented. Sure, we'll get to that too, but today we're gonna start here. So the second one we wanted was, oh, let's see. I guess we can do something like this. O.foo plus 1. So, or we can just do this even. This should turn into 124 in the end. And if we try to run this right now, it just fails because we don't generate bytecode for member expression. This last one here, so member expression plus 1. But no big deal, we can just add code generation. So okay. And then member expression generate Bytecode generator. Okay, so what do we do here? Well, we have this situation up here where we're handling member expression. This is when the member expression is on the left-hand side of an assignment expression. Now we're going to handle a standalone member expression, which doesn't need to resolve to sort of a reference, but rather it can simply, it just needs to compute or figure out whatever's at that property and return it. So the object register is still there. So we have the object. And then if it's computed, let's say again to do, so that we're not going to support foo plus 1 just yet. The computed version will only support the non-computed version. So non-computed version property should be guaranteed to be identifier. And instead of generating bytecode for a right-hand side, we just want to put out, now we make a get by ID. Yeah. And now we need a destination register. Generator, allocate register. And the rest is, let's see, destination and object reg. I think that makes sense, and then we just return it. Okay, so first thing is we compute whatever's on the left side of the member expression, and then if the right side is an identifier, then emit a get by id, store into a new register, use the object as base, and the property name as property. Yeah, okay. So let's add get by ID. Yeah, like when I see them, these names, at first I thought I wasn't gonna like them, but I guess I do like them because they remind me of WebKit, which has a special place in my heart, even though I didn't really understand these things in WebKit. But I understood them well enough to understand that this is what they were, like get by ID and put by ID, but I didn't. I always felt like I didn't understand JavaScript core as much as I would like to. And to a large extent, me working on libjs is very therapeutic because I'm sort of engaging with something that I previously thought was too difficult. I know I've mentioned this before in this series, but just reiterating here that this is sort of therapeutic for me because I used to think this was too difficult for me, and now I'm doing it anyway, and it feels nice. So here stuff just moves around a little bit because get has a destination instead of a source, because now we're not storing into the property, we're reading from it. And oopsie doopsie. But a lot of it is kind of the same because they both have a a base that needs to be turned into an object, but instead of object put, we need to do object get. And we need to store that into register destination. Klook. So let's see. Get by id. Well, that value at the end looks very promising, right? 124. So this is just commented out. So we're running this stuff right here. So we already did everything previously all the way up to this point, and now we're also evaluating this o.foo. So that starts here. Here's the put by id. Then this is finished, and then we fetch it out. First we fetch variable o, and then we read the property foo from it, and then we add together whatever the property contained plus constant 1. Very, very cool. That is pretty cool, actually. It just works. Okay, all right. So, like, yeah, I mean, obviously we're doing this, we're attacking this in a very simplistic way, right? Like we're just building the most naive variants or naive paths of these expressions. If you look at how the tree walk interpreter implements member expression execute, then there's more stuff going on. But not terribly much more. So it is pretty cool. There's probably a bunch of details that we need to look into. But the object of this series, what I'm hoping to create here is, in the past, I've always made these videos where I start working on something, but then I don't show like the same project in the next video and the next video after that, but rather I just jump around. And before I get back to something, there's usually other people working on it, or I work on it not in a video. So this series is the first time where I work on the same thing continuously, and I don't work on it in between the videos. So I do all the development here in the video. So I'm hoping that this will be sort of an interesting concept. I don't know. I'm very curious to hear what you think about it so far. So definitely leave a comment and let me know if you like the format. But obviously this is going to get to a point where I don't want to keep it to myself anymore. And that'll probably be before it's finished, like finished enough to replace the AST tree walk interpreter. So I don't know exactly when that is, like how far I want it to get before I push it to the tree, and ask other people to join. But I guess we'll see when we get there. So far, I feel like it's still, there are too many question marks and it's too immature, and I want to iterate on it and hack on it a bit. And this video series is a great side effect of that. So anyways, this is going to be it for this video. So if you made it this far, then I thank you for watching, for hanging out. I hope that you saw something interesting here, and I hope you're enjoying the series. And I guess I'll see you in the next video. Bye.